This is a short introduction video to scientific notation. So this is going to be just the basics of how to write numbers in scientific notation. The other day we were writing numbers to a power of 10, and so we're just going to refine that idea with scientific notation. Like the other day, we are using powers of 10 to write very small or very large numbers. The only difference between what we are doing today and what we did the other day was we have to make sure that the number that we are multiplying by a power of 10 is a number between 1 and 10. So for example, when we worked the other day in class, we were able to say like 85 times 10 to the third to represent this number, okay? Because they are equivalent. We've added 3 place values to 85. This would not be considered scientific notation because this number right here is not a number between 1 and 10. So we just need to make sure that we can adjust so that 85 is not 85, but it's a number between 1 and 10. So we would want it to say 8.5 because 8.5 is between 1 and 10. And then we have to adjust our exponent to show that we have another place value that decimal is going to need to move. So it's now going to be 10 to the fourth. It's going to give us the same answer. It's the same number. We just have to make sure that we're writing it correctly with scientific notation. In the first one, our decimal point was here and it's moved 3 places over. Now my decimal point started here and it has to move 4 places over. So the only difference is that we have to be really just careful about our exponent and making sure that the number is between 1 and 10. So if we look at this number, it's a fairly large number and we're going to want to write it in scientific notation. It's quite easy. Right now the decimal point is right there. So I need to move the decimal point until I get to a number between 1 and 10. So I'm going to move the decimal point over. And if I stop here, it's 45. I have to move the decimal one more place value. So it's going to become 4.5 times 10. And I have to look at how many place values I've moved. So I kind of count 1, 2, 3, 4, 5, 6, 7, 8. So it'll be 4.5 times 10 to the 8th. All right, let's look at another one. Same idea, it's a very large number. So I'm going to just start counting my place values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's going to be 13 place values. Notice it's not how many zeros there are, but how many place values I need to move. And my number is going to be 5.01 times 10 to the 13th. So I include that 01 because that's part of the number. Alright, let's look at this number. This number is small, so we have to make sure that our exponent reflects the fact that this is a small number and not a large number. But it's still counting our place values. So I'm going to count 1, 2, 3, 4, 5. So it's moved 5 place values. And because it's a small number, because I've had to move the decimal the other direction, and I have a small number, my exponent is going to be negative. Because when exponents are negative, we know that it creates a small number. It's actually a fraction that we have. So this would be 6 times 10 to the negative 5th. Alright, let's look at this one. We count our place values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And again, this is a small number, so it's going to get a negative exponent. And the number that I'm multiplying by that power of 10 is 8.022. And that's how it's written in scientific notation. Now let's look at this problem. It is already written in scientific notation, and we need to expand it to what's called standard notation. So basically, so we can see all the zeros. So what I notice is that the exponent is positive, which means this is representing a very large number. So it's 3.9, but it's times 10 to the 7th, so that means it's going to be 7 place values that I have to move my decimal. 1, 2, 3, 4, 5, 6, 7. So my decimal is now over there instead of over here. And I just have to add in some zeros for the place values that I've added. And again, you can notice that it's not adding 7 zeros, it's adding 7 place values. So in this case, I'm really only adding 6 zeros. So when I write the number out, I'll add in my commas so we can see what kind of number we've got. So we've got 39 million. All right, looking at this one, from the exponent of a -4, I know that I'm actually looking at a very small number. So I need to move my decimal in a way that will create a small number. So I'm going to move it 4 place values to the left. 1, 2, 3, 4. I'll add in my zeros. And again, it's not how many zeros I add, it's how many place values. So 0.000709. That would be my final answer. And the last one, 2 times 10 to the 9th. This exponent is positive, so I will be making a large number. And right now my decimal point is right there. I add in 9 place values. 1, 2, 3, 4, 5, 6, 7, 8, 9. And in this case, I am adding in 9 zeros because my decimal was at the end of the number. So it's a little bit easier because it's just 9 zeros. And we end up with 2 billion.